Continuation of the previous video, we were talking about the tympanal organs. So, in all insects, auditory organs functions as the displacement receptors responding to the disturbances of much lower intensity. They function by perceiving the pressure pulses which develop from the sound sources or by perceiving displacement of air causing vibrations of the membrane. The second wave is imprinting on the tympanum nerve cause it to vibrate. The vibrational movements stimulate the choroidal sensilla and the impulses are produced in the auditory nerve. The tympanum collects the energy of sound as it is the most delicate membrane and cannot be displaced easily since air-filled cavities behind it reduce the damping. The air cushions improve motility of tympanal membrane and amplify by resonance of certain frequency bands and thus improve the auditory sensitivity. The sounds are discriminated by the rhythmic variations in intensity which make up the modulation pattern and not by variations in pitch. The insects are, however, unable to discriminate between the sounds of different frequencies. The sound hearing organs are more sensitive to the high frequency stimulation. While in man, the auditory frequency is 1500 C per second. The characteristic of sound hearing of the insects is that they are able to locate source sounds. The time constant of the tympanal organs of insects is about 2 milliseconds or even less in comparison to that of human air, about 20 milliseconds. Due to such time constant, man cannot distinguish the sounds following one another at intervals of less than about 1/10th of a second, while insects are able to distinguish sounds separately by intervals of even 1/100th of the second, and insect tympanal organs are therefore 10 times more sensitive to recognize very rapid pulses of sound. Then static organs. The static organs are the proprioceptive organs, maintaining the equilibrium of the body and in orienting the insect with respect to gravity. The larvae of aquatic insect Limnophilus falciparis bears a pair of sacs in the last abdominal segment. Each sac is provided with a sensory hair at its blind end and granules or statoconia in the lumen. The sac is filled and emptied with water rhythmically by pumping action, which causes the statoconia to fall upon the sensory hair. In other insects, static organ is the vesicular statocyst containing movable statolith in the abdominal 10th and 11th segments. The nymphs of Nepa contain specialized static organs in the form of hairy sensory apparatus along the ventral surface of the abdomen containing a film of air. In adults, the apparatus is confined closely to the spiracles of 3 abdominal segments. They function as differentiated manometer and detect the hydrostatic pressure. Bathyceras or Bellostomatidae. So the surface of abdomen containing a film of air. In adults, the apparatus is confined closely. That Bellostomatidae bears a pair of static organs having the tactile hairs lodged in abdominal spiracles.